The moon isn't as static as it seems. It's not just sitting up there glowing peacefully, it's shrinking. Yep, the moon is getting smaller, and as it does, it's forming massive wrinkles across its surface. But why is this happening? And what does it mean for the moon's future and ours? Stick around, because this story is out of this world. We usually think of the moon as unchanging, a frozen rock orbiting Earth. But science has revealed that the moon is still evolving. Its core is slowly cooling, causing the moon to shrink like a deflating balloon. And as it shrinks, the surface is cracking, buckling, and wrinkling. These changes are reshaping our closest celestial neighbor in ways you've probably never imagined. But how did scientists figure this out, and what does it mean for the moon's stability? Let's explore the fascinating science behind the moon's shrinking. For centuries, humans believed the moon was a lifeless, unchanging sphere. It was a perfect backdrop for myths and poetry, a silent witness to Earth's history. But in 2010, data from NASA's Lunar Reconnaissance Orbiter revealed something surprising. The moon's surface is covered in thousands of cliffs called lobate scarps. These cliffs are the result of the moon shrinking over time. Here's the catch. Scientists didn't expect the moon to still be active. After all, it formed about 4.5 billion years ago. Shouldn't it have cooled completely by now? This unexpected discovery raised a big question. What's going on inside the moon that's causing it to shrink? To understand why the moon is shrinking, we need to look at its core. When the moon first formed, it was a molten ball of magma, like a miniature version of Earth. Over billions of years, that magma cooled and the moon's core solidified. But here's the thing, cooling doesn't happen evenly. As the core cools, it contracts. Think of it like a chocolate bar left in the fridge. It shrinks as it gets colder. This contraction pulls on the moon's crust, causing it to crack and form wrinkles. These wrinkles are the lobate scarps scientists have observed. Some of them stretch for miles and rise as high as 300 feet, like miniature mountain ranges on the moon's surface. But how do we know the moon is still shrinking? The answer lies in moonquakes. During the Apollo missions, astronauts left seismometers on the moon to measure its seismic activity. Decades later, scientists analyzed the data and found something shocking. The moon is still experiencing shallow quakes. These moonquakes happen near the lobate scarps, suggesting they're caused by the moon's shrinking crust. It's as if the moon's surface is struggling to adjust to its smaller size, creating seismic tremors in the process. There's another factor at play, Earth's gravitational pull. As the moon orbits Earth, it experiences tidal forces that stretch and squeeze its surface. These forces might be amplifying the effects of the moon's cooling core, accelerating the shrinking process. So what happens next? Will the moon keep shrinking until it disappears? Not exactly. The shrinking process is incredibly slow, just a few millimeters per year. But over millions of years, it could reshape the moon's surface dramatically. Here's what's really fascinating. The moon's activity challenges our assumptions about celestial bodies. We've always thought of the moon as geologically dead, but it turns out it's still evolving. This opens up new questions about other moons and planets in our solar system. Could they also be more dynamic than we thought? And let's not forget the practical implications. The moon's stability affects Earth in subtle but important ways. For example, the moon's gravitational pull influences our tides and helps stabilize Earth's rotation. If the moon's structure changes significantly, could it impact Earth as well? The moon may seem like an unchanging part of our night sky, but it's actually a dynamic, evolving world. As its core cools and contracts, the moon is shrinking, forming wrinkles that reveal its active past and present. These discoveries remind us that even the most familiar objects in our universe hold surprises.